A supervolcano could worsen climate change, and it might have already. Imagine you're making ramen noodles in your dorm room and suddenly the water turns to ash. You open the window and see smoke rising from the far side of campus. What do you do next? If the smoke is coming from the nearby Mount St. Helens National Volcanic Monument, you grab some supplies and head for the hills. But if it's coming from Yellowstone National Park, you make a beeline for the nearest bunker because Yellowstone is home to a supervolcano that could kill you. Supervolcanoes are volcanoes that have had eruptions thousands of times more powerful than regular large eruptions. They blow so much material out of their openings that they leave behind craters bigger than Manhattan. And while no one knows exactly how many exist around the world, there are about 1,200 candidates for supervolcano status. Some, like Yellowstone, are famous, others aren't, and most of them haven't blown up in a very long time. But here's something we hadn't appreciated until recently. A super eruption at one of these volcanoes could make global warming look like a walk in the park. In other words, an eruption big enough to wipe out life on Earth could also be catastrophic for the climate. Now you might be thinking, why should I worry about that? After all, it's not like there's a bunch of active supervolcanoes that could erupt at any moment. It's just that even though supervolcanoes don't blow up often, scientists say it's only a matter of time before one does. Plus, we know that supervolcanic eruptions can worsen climate change, but we didn't appreciate just how bad it could get until recently. When most people think of volcanic eruptions, they think of lava, but that stuff isn't even part of the technical definition of a volcanic eruption. Lava is molten rock that reaches the Earth's surface through a vent or fissure. The opening through which it flows is called a crater. So when we talk about the stuff that comes out of a volcano, we're really talking about ash, bits of rock and solid particles thrown into the air, hot gas and hot expanding rock. Gas and solid particles ejected during an eruption are collectively known as tephra. And while we usually use the term tephra to describe anything that erupts besides lava, different volcanologists define it differently. Some limit the term to rock fragments larger than sand, while others include finer particles. For the purposes of this video, though, let's stick with rock fragments larger than sand. If a volcano ejects more than 1,000 cubic kilometers of tephra in a single day, we call that a super eruption. To put that number in perspective, the most prolifically erupting volcano in the world, Indonesia's Mount Vesuvius, has never erupted that much tephra in a single day. Its biggest year was 1980, when it managed to eject about 3.6 cubic kilometers of tephra. And while the world's largest historical eruption, the 1815 eruption of Mount Tambora in Indonesia, came close to a super eruption, blasting out 60 cubic kilometers of tephra in a single day, it fell short of the mark. The distinction of being the largest eruption in recorded history belongs to Novarupta in Alaska, which blew its top in 1912, hurling 37 cubic kilometers of tephra into the air. That's more than 20 times what Mount St. Helens did when it destroyed a small town and killed dozens of people in 2004. But it's still nowhere near a super eruption. In fact, we've only ever recorded 2 super eruptions in history: Toba in Indonesia in 74,000 BCE and Krakatoa in Indonesia in 1883. Both caused massive devastation and long-lasting climate change. The problem is that super eruptions are impossible to predict. Even if scientists can spot the telltale signs that magma is building up under the surface of a volcano, or notice that the ground is bulging or that small earthquakes are happening more frequently, it's extremely difficult to know whether or not a volcano will erupt, and if so, when. For example, scientists have been monitoring Mount Vesuvius for decades, and they knew that it was due for an eruption. But despite all their monitoring efforts, they couldn't predict when the next one would occur. And because we can't predict when a super eruption will happen, scientists instead focus on understanding its potential effects. One thing scientists are sure of is that if a super eruption does occur, it will have both immediate and long-lasting consequences. In the short term, people and wildlife living near the volcano will face the same devastation that people and wildlife living near any volcano face. Ash and dust will blanket the landscape, destroying buildings, suffocating wildlife, and contaminating water sources. People will need to abandon their homes and entire cities may be wiped off the map. In the long term, the climate will feel the effects. When a volcano erupts, it doesn't just expel stuff that's inside the volcano, it also sucks stuff out of the atmosphere. Depending on the size of the eruption, it can remove 10 to 50 billion tons of carbon dioxide from the atmosphere. Normally that would be a good thing. After all, we're always looking for ways to get more carbon dioxide out of the atmosphere. But when a volcano sucks carbon dioxide out of the atmosphere, it also removes other stuff like water vapor and aerosols. And that throws the whole system into chaos. For instance, after Mount Pinatubo in the Philippines erupted in 1991, it removed about 2 million tons of sulfur dioxide from the atmosphere. That led to a decrease in global temperatures that lasted several years. The removal of sulfur dioxide was good news for humans. But the removal of water vapor and aerosols was bad news for plants, which need those things to photosynthesize. As a result, plant growth slowed down for a few years after Pinatubo erupted. So while a super eruption would remove lots of carbon dioxide from the atmosphere in the short term, it would also remove too much of everything else. And that would lead to a cascade of negative effects that could last for decades. Even worse, some scientists think that a super eruption at a particularly unlucky volcano could cause a runaway greenhouse effect. Most scientists agree that if a supervolcano were to erupt today, it would cause global temperatures to plummet. That's because the ash and aerosols would reflect sunlight back into space, causing an ice age. But some scientists think that if the magma plume traveled high enough into the atmosphere, it would actually trigger a greenhouse effect instead. Normally, water vapor is the main thing that causes the greenhouse effect. Water vapor from the oceans evaporates and forms clouds that trap heat from the sun. The trouble is that when a supervolcano erupts, it puts all kinds of non-water stuff into the atmosphere, which doesn't trap heat very well. After the initial explosion, though, water vapor in the upper atmosphere would start to condense on the ash and aerosol particles, forming thick clouds. Those clouds would trap heat and temperatures would rise. The problem is that the ash and aerosol particles would absorb most of the ultraviolet radiation from the sun, which would damage the ozone layer and weaken the protection it provides from harmful radiation. So if a supervolcanic eruption reached high enough into the atmosphere, it could simultaneously disrupt the normal balance of gases in the stratosphere and destroy the ozone layer, leading to runaway global warming. So far, none of the major eruptions we've discussed have punched through the stratosphere. The highest that Mount Tambora's plume went is unknown, but most researchers agree it didn't go higher than the tropopause, the boundary between the troposphere and the stratosphere. The highest plume ever recorded was created by Mount Pinatubo. It reached 35 kilometers up through the troposphere and 30 kilometers into the stratosphere. But that's not to say that supervolcanoes can't punch through the stratosphere. After all, Mount Toba's eruption threw so much material into the atmosphere that some scientists speculate that it created a second stratosphere above the ozone layer. If that's true, it means that its plume reached higher than any eruption since humans have been keeping records. And that means that one of the deadliest and most destructive events in the history of our planet could also kick off another mass extinction event. Scientists don't agree on whether or not a supervolcano could punch through the stratosphere, but recent research suggests it's possible. In 2023, one team of scientists published a paper arguing that the stratosphere we know today wouldn't exist without the eruption of Mount Toba. They based their argument on chemistry. Here on Earth we normally find nitrogen in its diatomic form, N2, but in the stratosphere we also find a lot of nitric oxide, NO, and it's unclear where all that nitric oxide came from. One idea is that it came from lightning strikes on Mount Toba's plume, which would mean that the plume reached into the mesosphere, the layer of atmosphere above the stratosphere. If that's true, then it means that future super eruptions could punch through the stratosphere and disrupt the balance of gases in the atmosphere, possibly triggering runaway global warming. It's hard to say just how bad the climate consequences of a super eruption would be because we've never seen one before. But we do know that super eruptions are inevitable, and we know that they have far-reaching effects. So while we hope it never happens, we should prepare for the possibility that one of the world's supervolcanoes might blow.